hanging out now at the comfortable hour of noon. Oh, did you start recording already? All right, good. Woo! 7th period. Hello. And other people watching at home. I have so many fans on the internet. And also the people who are currently in this room. 9th period. Yesterday, we spent basically an entire 45 minutes talking about Poincaré, his mathematical philosophy, and we're going to wrap this thing up today. We're on slide 100 of 150, because the person who made this presentation really went all out. Yesterday, we talked about Lutzen Egbertus Jan Brouwer, the Dutch mathematician at the turn of the 19th to the 20th century, founder of this branch of, I'll call it a branch of meta-mathematics, but also kind of a branch of mathematics called Intuitionism. And we started to talk about this yesterday a little bit. The lead-in to this part of the presentation was discussing this function defined based on the truth of the twin prime conjecture. And I think we ended somewhere around here with some discussion of why you might consider the law of the excluded middle to be false. Okay, so this guy Leopold Kronecker has come up in this class before. He's the one who was like bullying Cantor. Remember how Cantor had various like nervous breakdowns because of all of the controversy and all of the professors, the German professors who were like mean to him. The main one was this guy Leopold Kronecker. And he is another, like Poincaré, he is a kind of pre-intuitionist in the sense that he's not an intuitionist proper, but he was very influential in bringing constructivism back to mathematical prominence. And he was what's called a finitist. So in contradiction to, or in opposition to Cantor, he believed, Kronecker, that there just were no infinite objects, full stop. So this philosophy, or this position, finitism, some people even call it ultra-finitism, is the position that there just is no infinity. Never mind potential infinity, actual infinity, all this kind of crap. We just live in a finite world with like a finite number of things, and there are just only a finite number of stuff, and only finite math really makes any sense. This is seemingly against everything that we normally, at least the way we teach math now in 2019, where we constantly are talking about the natural numbers and the real numbers and thinking about there being an infinite number of even rationals between 0 and 1. Kronecker thought all of that was just nonsense. He really only believed in like the natural numbers, and I guess even then, like not all of them. This guy Kronecker is was a big he was an enemy of Hilbert's and Cantor's, and was another person who, because he was so famous and powerful, influential, kind of laid the path for Brouwer. All right, and he has this famous quote: "God made the natural numbers; all else is the work of man." Whatever that's supposed to mean. People quote that all the time, which is just to say that really the only real mathematical objects are the natural numbers. Everything else is just some stuff that we just made up based on that. That stuff's not real. Hilbert really did not like these freaking intuitionists. He was very mean to them. There's this whole like 30-year flame war between Hilbert, the formalist, who you could think of as continuing the tradition of Weierstrass and Cantor, to doing what you would think of as mainstream mathematics, trying to fix everything, and this he considers to be some new weird cult, basically, this cult of intuitionists. And Hilbert is motivated, and we're going to hear an entire other presentation later this week or maybe next week on Hilbert's program. Hilbert's program, loosely speaking, is the program that Hilbert comes up with to try to fix mathematics in light of Russell's paradox. And he is sort of in a war with the intuitionists, who feel that, in fact, the big idea behind Russell's paradox and the axiom of choice and all of these other very abstract branches of set theory is to just abandon all that crap and to just go to some spookier, stranger position in the philosophy of mathematics, which is the position of the intuitionists. All right, Hilbert is just perplexed. He says he's astonished that a whole community of mathematicians he's astonished that the power of suggestion of a single man, however full of temperament and inventiveness, is capable of having the most improbable and eccentric effects. He's referring to Brouwer. Really, this entire branch of mathematics, intuitionism, is really just down to this one crazy guy, Brouwer, who writes this paper in like 1905, and it's just kind of like, it catches people right at their lowest point when they just have no confidence in what's going on, and suddenly, like, 20% of the world's mathematicians are sort of converting to Intuitionism, and Hilbert is shocked and appalled by this. Okay. Skipping around. Yeah. All right. So what are we trying? So what kinds of challenges does Intuitionism face? Well, they need to somehow kind of explain what it means for mathematical objects to exist. But okay, so Platonism. I don't like this slide. Moving on. Okay. Intuitionism, this is what's so crazy about it, does not assume any kind of actual mathematical reality. Intuitionism, and this is kind of what we ended with yesterday, believes that the real mathematics is happening inside of the minds of individual, like, human beings. Yeah. And also, as we discussed yesterday with respect to the twin prime conjecture, that mathematical truth has a kind of a temporal aspect to it. That the twin prime conjecture, when we prove it, is now true, but until or becomes true when we prove it, and if it turns out that we find out that it's false, it will become false. But until then, it's just sort of merely nothing. Okay, and as I've kind of been saying, Intuitionism you can think of as closely associated with constructivism, which is something we've also kind of briefly talked about here and there. The constructivists are those who believe that the only mathematical objects are the ones that you can explicitly construct. So these were the constructivists were the people, I don't know how much Reynold talked about this, but these were the people who really didn't like the axiom of choice. The people who reacted hard to the axiom of choice were the people who thought that it just made no sense to define a function such that you could take one element from each subset without actually giving the rule for which object to take. And constructivism, broadly speaking, is the view that in order to be able to be allowed to use a mathematical object or to show that it exists, you need to be able to construct it. They're influenced by Poincaré, but really, as I've been saying, Intuitionism is due to this guy Brouwer. Okay. He is a tricky guy, and we'll hear at the very end of the presentation a little bit about his life. He's kind of a jerk, too. Not a sympathetic character at all. And he changed his mind a lot, and because this is an entire branch of mathematics, there were sort of different opinions, so you can't exactly point to precisely what the Intuitionists believe on every single issue, because it's a wide category of people. Okay, he writes these two papers on the foundations of mathematics in 1907 and the unreliability of the logical principles. These are both in Dutch. This one is over de grondslagen der wiskunde, so on the foundations of mathematics. And this one, I'll just say something about this. So this is the, okay, don't get the impression that I really speak Dutch, because I definitely don't. I'm like,
I've been here 3 years.
I'm like, I would be like, my Dutch is as good as like someone who's like week 7 of like Dutch 101. That's kind of like how good I am. So like that. But anyway, I do know some things. So the unreliability, this doesn't, this is this standard English translation, but in Dutch this is the onbetrouwbaarheid der logische principes. And this word onbetrouwbaarheid, so betrouw is like the word for married, right? So this is like, it has this connotation that's like far more like extreme, like onbetrouwd is like betrayal or something like that, right? This is like the infidelity or something like that, right? So this is like you should think of the unreliability like the basic principles of logic, such as the law of the excluded middle, is like a cheating spouse or something like that, which has led you astray, and these are unreliable. Okay. Woo. What do these Intuitionists believe? Well,
if you can construct something in your mind, then it exists. Mathematics is like some kind of experience that you have. And the only objects which don't exist are the objects which somehow cannot be constructed in your mind. By the way, I confess that I might not fully understand Intuitionism. So I'm not 100% sure that I'm giving like an accurate portrayal of this, because I've put a lot of time and effort into it, not this year, but other years, and I don't totally get it, although I have a sense of what they're talking about. This is Brouwer, and I read some of Brouwer's original works. He says that true math, real math, has no language associated with it. The only thing that's really true is like what's in your head. And the things that we typically call math, the stuff when we're doing math now, we're talking, we're writing things on the board, we have equations. All of that is not math. That is just descriptions of the math. And the real math is the math that's like going on in your head. And all the things that we write down in books and papers and textbooks and the conversations we have and professors lecturing and people asking questions, all that is just us describing math, and then we're describing what's happening in our heads. Axioms have no real meaning. Logic, he has nothing but complete disgust for, similar to Poincaré. Logic, he speaks of it as the study of linguistic patterns in our mathematical descriptions. Okay, so logic is somehow like 2 steps removed from like the real thing that's going on, right? The real thing that's going on is the math that's in your head, man. And then everything you write down is already kind of like a degraded form of that or something like that, right? This is now just the linguistic description. And logic, that's just even stupider. That's just the study of the various patterns that emerge in our descriptions of the real thing that's going on in our head. And so logic is completely derivative of mathematics, and similar to Poincaré, he thinks that the attempt by the logicists, which is, by the way, this is going on at the exact same time, 1907, this is like Bertrand Russell's like writing the Principia, that these people are just have it all backwards, and trying to base mathematics on logic is ridiculous. This is what Brouwer thinks. So here we go. This is a direct quote, I think, or maybe it isn't. Yeah, no, I think this is an actual quote from him, of course translated. The truth of a mathematical statement can only be conceived via a mental construction that proves it to be true. And the communication between mathematicians only serves as a means to create the same mental processes in different minds. And so I have some true math going on in my head. If I want Preyak to have that same math going on in his head, then we engage in some kind of communication. But the communication is just my way of making the math like jump to his brain. But don't mistake the communication for the real math. The real math is going on in your head. Here we go. This is definitely a quote because it's so ridiculous. Let's do it. I like this. The languageless constructions which arise from the self-unfolding of the basic intuition are exact and true by virtue of their presence in the memory. But the human faculty of memory, which must survey these constructions, is by its nature limited and liable to error, even when it seeks the support of linguistic signs. Thus, for a human mind equipped with an unlimited memory, pure mathematics, practiced in solitude and without using linguistic signs, would be exact. But the exactness would be lost in mathematical communication between human beings, even with an unlimited memory, because they would still be thrown upon language as their means of understanding. Okay, there's a lot going on in this quote. Yeah, this is what you think about math tests.
Why I fail on a math test.
Oh, because you get it in your own brain, but then when you go to like write it down, you like mess up or something,
Yeah,
right?
that's it.
Yeah, good. You should explain to Schwartz. I told him he's never heard of Intuitionism before. I told it to him once. He almost puked right on the spot once he understood what I was talking about. He's like, what the hell is this crap? Mainstream mathematicians really kind of hate this, but you can sort of see where Brouwer's coming from. He's like, because also you have to put yourself back in the moment, right? It's 1908 or something like that. All of math is just collapsing around us. Everything's based on set theory. Set theory is contradictory. We have the acceptors. We don't know what's going on. Things are spiraling out of control. Oh no, what are we going to do? Brouwer says there's a reason why everything is out of control. The reason why everything's out of control is because the real math, man, happens in your head. Also, by the way, he sets it up in such a way that like true math, what he calls exact math, is almost never happens, because also we just like suck at like thinking, right? We do have a limited memory. We mess up. We can't survey. Even like if you're some sort of tryst grandmaster or whatever, you still like screw up every now and then. You forget something, or you're missing the big picture. And so we are forced, because our memory is so poor and our processing powers are so poor, we're forced to resort to linguistic signs, and in order to help us. But he says, even with the only exact math is the math that would happen practiced in solitude and without using linguistic signs. Isn't this kind of crazy? This image of math is like you have to just be alone in a dark room all by yourself, never write anything down and never tell it to anyone. That's like the real math. And as soon as you begin to lean on linguistic signs as a crutch to help to supplement your poor processing abilities and ability to keep things in your short-term memory, that's when things start to go awry. And because these linguistic signs don't capture the true purity of the mathematical ideas, then things start to go a little bit awry. And he thinks that Hilbert, who is, we'll hear more about Hilbert's philosophy of mathematics later, but the people who believe in axiomatic mathematics place the axiom at the absolute peak of prominence. Right? The axioms are the only important thing. This came up in Hilbert's geometry presentation a little bit, right? That really we should just take the axioms as the true mathematics, and we shouldn't even spend our time thinking about what they even really mean, right? The axioms are the real thing. This is like the other end of the spectrum. This is like, no, those are just the symbols that you had to use so that you could keep it all straight in your head. And then as soon as you try to talk about it with someone else, forget about it. Now we are forced to be thrown upon language as our means of communication, and the language can't capture it, so we lose it. He thinks that because we cannot create actual infinity in our brains, then there's just no actual infinity, and sets of infinite size are ridiculous because they can't be constructed. Transfinite, I don't even know what he thinks about transfinite, so I won't pretend. All right, maybe not going to read this whole quote. This is not actually 1981. This must be something that was published after he was dead. But he has, Brouwer thinks that there are two fundamental intuitive things intuitions. He calls them the first act of intuitionism and the second act of intuitionism. Okay, this is crazy. The first one gives rise to the natural numbers. Okay, what is this act? He says, okay, completely separating mathematics from mathematical language, and hence from the phenomena of language described by theoretical logic. Recognizing that intuitionist mathematics is an essentially languageless activity of the mind having its origin in the perception of a move of time. What? This perception of a move of time may be described as the falling apart of a life moment into two distinct things, one of which gives way to the other, but is retained by memory. If the tuity thus born is divested of all quality, it passes into the empty form of the common substratum of all tuities. And there's this common substratum, which is the, okay. What? I think what he is saying is that this is, again, you should again think of this as a kind of a Kantian type position. That somehow, based on the fact that we are thinking beings who like experience time in some linear progression, we all have, in an undeniable way, this feeling, memory, intuition, whatever you want to call it, of like a moment becoming two moments. And this is two. And this one becoming two, like that's like a successor function or something like that. And that is like, that's like natural numbers. Okay, so somehow we have to give ourselves natural numbers because we have an intuition so strong that we can't possibly not have it, of one becoming like two, and it is this common like tuity. Okay, let's keep going. Woo! The second act of intuitionism, this is similar to Poincaré, we talked about this a lot yesterday, how he felt that you should just take the real numbers and not talk about them too much. Brouwer thinks that we also just have the continuum. So admitting two ways of creating new mathematical entities, first thing in the shape of, let's see, sure, let's move on. Good, he feels that we just have the continuum. Okay, I've sort of already said this, logic he thinks is just,
the study of patterns in linguistic records of mathematical acts of construction. And you can't actually get any mathematical truth from logic. These people, these poor, pathetic people sitting down there getting axioms and doing Fichte-style proofs, they're just like manipulating symbols around without any kind of understanding, and how are we going to get truth that way? Truth doesn't come from manipulating symbols. The symbols are the description of the real times we had together. That was a joke. Okay. Mathematics. This is a dumb joke. Okay. It didn't even make any sense. Mathematics is nothing more, nothing less than the exact. Okay. There's too many quotes. La 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 la. Yeah. Boom. Great. He loves induction, and this is the part that really what's going on first? Good. Woo. Yeah. So, basic principles of propositional logic, which have held from the time of Aristotle all the way up through Hilbert and everyone. Principles of the syllogism, so like if A implies B and B implies C, then A implies C. Principle of contradiction, I don't know why they're calling it that way. I don't know what that even means. And the law of the excluded middle, Brouwer challenges these. I said this yesterday. The principle of the excluded middle, in particular, the fact that everything is either true or false, he thinks that this is just wrong. And that if we want to fix mathematics, one thing we need to do is to change the background logic that we're using, and to rephrase sort of mathematical truth as like the existence of a construction. And as we talked about yesterday, the twin prime conjecture, having not been proved yet, it's just wrong, says Brouwer, to say that the twin prime conjecture is either true or false. Until we show it to be one or the other, it's just nothing. If you therefore become an intuitionist, your break with the rest of mathematicians is going to be pretty severe. If you have all of the basic mainstream mathematicians who are using essentially what we might as well call classical logic, the logic as I taught it to you, throughout this whole semester, and then the intuitionists are just using fundamentally like an entirely different logical principles, it's hard to imagine how these two groups of people are gonna communicate with each other. Okay. Another interesting, I think maybe this is the law of contradiction. This is another interesting logical principle which Brouwer rejects. Not P implies P. Brouwer says it's invalid. Okay, let's try to understand what this means. Asserting P no longer means sort of that P is true. Asserting P, or maybe I should just say P, is really saying that there exists a mental construction that verifies P or something like that. And so not P somehow does not imply P, because P means you have a construction that shows P. Not P somehow means that you don't have a construction that shows not P. But just because you don't have a construction that shows not P doesn't mean that you do have one that shows P. Something like that. This ends up being, I don't want to skip around too much, but this ends up being actually really influential. Well, I'll say this later. Okay. All right. This is now getting really into the one year. This girl who made this presentation just put so much effort into it that I was like, damn, I should too. And I sat around also spending like 12 hours like reading up on this crap on the internet. And at some point I finally started to understand Intuitionism a little bit, the details. And now I've forgotten a lot of it. I kept seeing this phrase come up over and over again, weak counterexample. And the 100th time I was like, I better try to figure out what the hell a weak counterexample is. Okay, so the intuitionists have just a completely different view of mathematics. And a completely different view of the real numbers. Okay, so let's spend a couple minutes on this. Take this proposition. Let's call it A. And here's what this proposition says. For any n greater than 2 is the sum of 3 primes. Okay, this is actually the original Goldbach conjecture. The Goldbach conjecture that we presented 2 days ago, or yesterday maybe it was, was every even number. Wait, am I messing this up? No, that's right. Every even number greater than 2 is the sum of 2 primes, right? Yeah. This is that just any number greater than 2 is the sum of 3 primes. Why are those the same thing? Yeah. Is that obvious? Yeah.
So like if you have an even number, that's the sum of 2 primes, add 1 to it. That is another number that is equal to the sum of 2 primes plus 1. Well, no, 1 isn't a prime.
No, just
So
plus
never
3.
mind.
Plus 3 is...
Plus 3, yeah, plus 3. Because
And then minus 2.
Yeah, wait. These are equivalent to each other, but you guys get it, but I don't. I just need a second to think about it.
Like take an odd number.
Yeah.
And then like subtract 3 from that odd number. And so now you have an even number. And so if an even number is a sum of 2
Oh,
primes,
sure.
then it's plus 3.
There you go. Yeah. Yeah. If this is the original Goldbach conjecture, every number is the sum of 3 primes. So he says, well, first of all, suppose the other Goldbach conjecture is true, right? Suppose every even number greater than 2 is the sum of 2 primes. Well, then if you give me an even number, it's the sum of 3 primes because no. If it's even, then just take 2 off. Is that kind of what you're saying?
No.
If it's even, yeah. If n is even, take off 2, and then what's left is still even. So then using the Goldbach conjecture from last class, then you have 2 primes plus 2. And if it's odd, take off 3. Anyway, these are basically like equivalent to each other. Although nowadays when people say the Goldbach conjecture, they mean the other one from last class. But anyway, so okay. I like this better for this example because this is now something which is either true or false of every single number greater than 2. Okay, so just between me and you, if this conjecture is true, it seems to be true, then this proposition is just true for every single natural number forever. Okay, this is not speaking as an intuitionist. All right, so here's the kind of weird crap that the intuitionists do. They go like this. All right. So here it is. The original Goldbach conjecture is just the statement that for all n, a of n. This is unproved as of 2020. This is still unproved. So to an intuitionist, this is neither true nor false, this statement. Okay, so now the intuitionist will do some weird crap like this. They'll say, all right, consider the following sequence. Can you guys read this? Is that a no? How do I zoom in a PowerPoint? Or I just do a better job of making the PowerPoint to begin with? There we go. Yeah. Okay. So, do the following. For every single number, create the sequence in the following manner. If for all the numbers m up to that point, the Goldbach conjecture holds, then let this next number in the sequence be 1 over 2 to that number. Okay, and if instead you hit a number n such that there is some m less than n for which the Goldbach conjecture is false, so if it's not true that a sub m and m is less than n for some m, I guess, and for, what the hell is this saying? I see. I am missing kind of part. In other words, let m be the point at which the Goldbach conjecture is first false, right? That's the simple way to put it in words, right? Let little m be the first number which cannot be expressed as the sum of 3 primes, and then let this sequence become constant from that point on. Follow? Okay. So zooming back out now. So now, if in fact every number is the sum of 3 primes, then this sequence will just be 1/4, 1/8, 1/16 forever. Okay? And it will converge to 0. This takes a kind of a Cauchy-like definition of a real number as an infinite sequence of rational numbers. And so the way that a intuitionist views the real numbers as kind of views a real number as kind of an infinite sequence of rational numbers. And so if the Goldbach conjecture is true, then this real number is just 0, in fact, because it's an infinite sequence of rationals which converges to 0, and so it's just 0 in a kind of Cauchy sort of sense. But instead, if there is some number that's not the sum of 3 primes, then eventually this sequence just kind of gets stuck at 1 over 2 to the m, and so this real number is not 0. Okay, so basically, okay, I don't know if this is a good use of class time or not, but what the intuitionists have done is they've made their job way, way harder for themselves. Because what does it mean to be a real number to an intuitionist? Well, the only real numbers that they're allowed in their world are real numbers which can be like constructed. Okay, but what does it mean to construct a real number? Well, it means you need to give some like explicit algorithm for like computing that real number or something like that. And this is an explicit algorithm, so this does define a real number because it tells you exactly how to sort of make this real number or something like that. But because we don't know whether the conjecture is true or false, we don't know whether R is 0. And therefore, this is my attempt to try to give some example of why an intuitionist would disagree with the law of the excluded middle. Now we kind of got into the details of it a little bit, right? An intuitionist believes that the statement R equals 0 or R is not 0 is false here. I can't say that R is 0 or R is not 0 in this case because I don't know, not knowing the truth of the twin prime conjecture, I don't know whether this real number that I just defined is in fact 0 or is in fact something else. And not knowing either of these means that I cannot assert the disjunction of them. And all that, the talk of the sequence was there to explain to you why this was a real number according to the intuitions. All right, you kind of like half got that, or even like 10%, good enough. Woo! I think we're kind of almost at the end here. So I should say that Brouwer writes, very freely all of these papers. He becomes extremely influential. It's like a sensation. It starts in the Netherlands and it spreads throughout Europe. And suddenly, like one by one, all these people decide, like, yeah, intuitionism is the way to go. And they start doing math in a totally different way. Later on, these other people, Heiting and Kolmogorov, I think Heiting is Dutch for sure, Kolmogorov might be German or something else, they tried to formalize intuitionist logic. And this is not necessarily something that Brouwer thought was a good idea. But in order for intuitionists to be able to communicate with other mathematicians, there was some mainstream mathematicians were like, dude, intuitionists, like, what the hell are you doing? Can you like explain like what principles are valid? And so an entire other branch of logic called intuitionist logic was formalized by other people in the intuitionist school, not Brouwer himself. And if you actually intuitionism as a true movement that people really believe in is kind of dead. It has some few numbers of adherents actually still in the Netherlands, but basically no one